In this session, we will discuss about the source coding first principle. So this is a very important and useful principle in order to apply for the source coding. So I will try my best to describe this session very well so that you can understand what is basically the Huffman code and how you can implement this Huffman code in practical applications. So, what is basically the Huffman coding is Huffman code words are specially allocated in order to minimize the average code word length and therefore maximizing the code word efficiency. Like usually, if you are not using Huffman code, so it means that the number of bits that you are using for each message that is a fix, so that will use more bandwidth, so that it means that you need to compress your data, or you need to change the length of a uh, message or the code word, so that you can, if you vary the length of the code word, in that case the code word efficiency will be increased and the code word length will be decreased. Short code words are used to represent frequently occurring message possibilities, and long code words are used to rear one. Like uh, you can use the short codes for those messages who are occurring many more times as compared to those messages who are occurring very rarely. More specifically, the message possibilities I is allocated a code word Ci having an integer value length Li that is typically close to the possibilities information content, and we know the definition of the information content is log 2 of 1 by probability of that symbol. So in this slide, we will try to explain the procedure of the Huffman coding, or you can say the principle of the Huffman coding, that how can you apply the principle of Huffman code when you want to draw a code word, or when you want to write a code word by the giving probabilities of a certain symbols. So the first step of the Huffman coding procedure is that the source symbols are arranged in order of decreasing probability. So it means that you have to write the symbols with highest probability at the top, then the two of the lowest possibility lowest probabilities are designed, like, and then you need to see, once you assigned once you do the arrangement of decreasing probability, then you need to select the two messages which has a very low probability and assign them a bit 0 1. So I'm talking about the binary uh, message, like if the data is binary, like only then in that case you have 0 and 1. So, and the second step is combine last two symbols and move the combined bit symbols as high as possible. So you need to combine these assigned values and then add the probability of these assigned uh, symbols, and then arrange these symbols as highest as possible. But you need to keep in mind that the highest probability will always be upstairs, or always be on top. The third step is that you need to repeat step 1 and 2 till end. Code for each symbol is found by moving backward. So you need to consider the formulas that will be used in a few examples. Like the code efficiency will be equals to the entropy divided by the average code word length multiplied by log 2 of gamma. So this is basically gamma is given for, if you are talking about the binary, so then its value is equals to 2, and symbols you can use 0 and 1. But if you are talking about the ternary code, then R gamma will be equals to 3, and the symbol 0 1 and 2. But if it is quaternary, then its value is equals to 4, and the symbols are 0 1 2 and 3. But in this session, we will discuss about the binary case, like gamma is equals to 2 So you can even write the formula h divided by average code word length, because we know that the formula for log 2 of gamma, if it is equals to 2, so log 2 of base 2 is equals to 1. So this formula can be equals to h divided by l. L is the average code word length, so that is equals to summation of symbol from I is equals to 1 to n, the product of the probability of ith symbol multiplied by the length of the code word length, or you can write the length of the bits. So h, we know already the formula of h, that is equals to the summation from I is equals to 1 to n, the probability multiplied by the information, and the variance is equals to I is equals to 1 to n, the probability multiplied by the number of bits, and minus average code word length, number of bit I in a particular code word. So let's try to solve one example so that we can better understand that how can we implement this Huffman code for the binary case. Alphabet with the probabilities zero point 0.4, zero point 0.2, zero point 0.2, zero point 0.1, and zero point 0.1 for symbols x1, x2, x3, x4, and x5. We need to calculate the Huffman code efficiency, and variance. So we will try to apply the Huffman code procedure in this example. The first step was the assignment of the symbol, or arrangement of the probability. Like here you can see the highest probability is on top, that is zero point 0.4. Here in this side their symbol as 1, 2, 3, 4, and then 5. The probability on top is zero point 0.4, and then zero point 0.2, zero point 0.2, and then zero point 0.1, and then zero point 0.1. So these two symbols have the lowest probability. So you need to combine them. Okay. So you need to combine them with the bit 0 and 1, because we are talking about the binary. So the value of gamma is 2 and the symbols are 0 and 1. So if you combine them, the answer will be equals to zero point 0.2. So you can take as highest as possible, but you cannot take on top of the 4, because zero point 0.4 is bigger than zero point 0.2. So that is why you can write zero point 0.2 is here, and then zero point 0.4 is here. So this zero point 0.2 will be here, and this zero point 0.2 will be here. From these three, you can again combine the two probability symbols. The least is zero point 0.2 and then zero point 0.2. You can combine zero point 0.2 and then zero point 0.2. So you can assign the symbol 0 and then 1. So you need to always assign 0 up and 1 down. So 0 up and 1 down. So then you can the combined answer is zero point 0.4. So zero point 0.4 here, so zero point 0.4 is there. So both are equal. So that means that you need to take this zero point 0.4 on top, because zero point 0.4 and zero point 0.4 are equal. So you have to go on top of that zero point 0.4. So this zero point 0.4 will be here, and then this zero point 0.2 will be here. So you can combine these two together with the two symbols 0 and 1, and then if you combine them, so the answer is zero point 0.6. So zero point 0.4 plus zero point 0.2 is zero point 0.6. So you need to take this zero point 0.6 on top, and this zero point 0.4 will be there. And then you can again combine these two, and this is 0 is upstairs and 1 is downstairs. And then you need to calculate the code word. So for each symbol S1, S2, S3, S4. So the first symbol is S1. So this is S1. So you need to start from here. So from this is the path from here to there. So and then this path, and then you can see this path. So this path, and then from here to this path, and then from here to this one. And then when you assign code word, you need to go backward. So from here to backward, so this is 0, and then from here to here, this is second 0, and then from here to here. So it means that 0 0. So what is the length? So 2 bits, so that is why you write here 2. The second is S2. So this is S2. You need to move from here to there, and then this is 0, and then there, and then there, and then from here to there, and then its end. So when you need to see the code word, you need to go backward. So this is 1, and then here, and then this one, and then this is 0. So it is 1 0. So S2 is 1 0. For S3, we need to move from here to this one, and then go up, and then from here go there. So this is moving backward. So 1, and then again 1. So you see, and then this one. So S3 is 1, and then 1, and the length is 2. So S4 is from here, and then from here. So this is the path, point 2, and then from here. So this is the path, and then from there. So when you need to code word, go backward, 0, 0, 1, and then you see this is 0. So 0, 1 is 0, 0, 1, 0, the length is 3. So 5, from 5 here move 1, and then there, and then there, and then there, and then there. So you see, then assign code word 0, 1, 0, 1, and then you see it's 1. So 0, 1, and 1. Then what is length? 3. The second step, you need to calculate the entropy. So entropy is equals to the probability multiplied by the information. So probability of first message was zero point 0.4 log 2 1 by zero point 0.4 plus we have two messages with probability zero point 0.2, so that is why you multiplied with the 2.2 log 2 1 by zero point 0.2 plus you have two messages with the probability zero point 0.1, so that is why you multiply 2 with zero point 0.1 log 2 1 by zero point 0.1. Yeah. Sorry, it should be 1 by 0.1. The 1 is missing here. So if you calculate using your calculator, its answer will be equal to 2.1216 bit per second. The second question was to calculate the efficiency. So for efficiency, you need to calculate entropy, that you have already done there. The second step, you need to calculate L, that is average code word length. Then you need to use this formula, that is the product of the probability multiplied by the number of code word bits. First one, probability zero point 0.4, the code word bit, we know the code word bits are 2. So that is why 2. Second, 2 and 3 have probability zero point 0.2, so that is why you multiplied with 2, because messages are 2. So then you multiplied with the code word length. So both has 2 code word length. So 2, 2. So that is why you multiplied by 2. The third and fourth and fifth messages has probability zero point 0.5, so that is why you multiplied 2 with the probability, and both have the code word length, that is 3, so that is why you multiplied with 3. The average code word length will be equal to 2.2 bit per symbol. Then you can see the efficiency, that h divided by l multiplied by log 2 of gamma. So here gamma is 2. We are talking about the binary case. So log 2 of 2 will be equals to 1. So the remaining is h divided by l. H is calculated. So use the values multiplied by 100. The answer will be in percentage. That is 96.4%. The other parameter that you need to calculate is the variance, which is equals to summation probability multiplied by ni minus l whole square. So ni is the number of bit in a particular symbol. So the first probability is zero point 0.5. The number of bit we have 2. So the number of bit we have 2. So the average code word length is 2 by 2 whole square, plus we have two messages with probability zero point 0.2. So that is why you multiplied with 2. We know that the code word length is 2. So that is why you write 2. Average code word length is 2.2 whole square. We have two messages with the probability zero point 0.5, so 2 multiplied by zero point 0.5. The length of the code word bit is 3, so that is why 3 minus 2.2 whole square. It should be whole square, so square is also missing, so better you need to write here square. Okay, so then use your calculator, calculate the answer. The sigma square will be equal to 0.16. So it is better that the value of the sigma square should be as low as possible. So that's all for this session. I hope that you have understand the Huffman coding procedure for the binary case, and we have solved one example as well. So I hope that you understand the example as well. But if you have any confusion, you can ask. Thank you for watching the video.